We've done it. Predicted paper 3 is live. So this predicted paper is based on topics we've not seen yet. Now, there are actually a lot of topics we've not seen yet, and I couldn't cram it all in with 80 marks. So what I've done is tried to select the ones that are most common out of all of them, put them in the predicted paper, and in the description below, I've just got some links to some quick revision walkthroughs to the other topics. Do your research, make sure you are covering all bases. I'm sure your teachers have given you lists as well, so obviously do use them. These questions are bespoke, they're unique, they've been handwritten. You will not see them anywhere else, which makes them absolutely fantastic resource for your preparation. As before, I'd recommend just downloading the paper, quietly working through, and then using the video to mark and get fully worked solutions if you need them. Okay, so let's get on with this. Okay, our first question is right, 0.7 is a percentage. Now the 7 is in the tenths column. We obviously want it over 100, as that's what percentage means. So we're going to need to times by 10. And when you times by 10, you'll get 70 on the top. So 70%. Write the number 2,408 in words. Now, the and here is really important. If we don't have the and, we don't get the mark. Literally write it how you say it. Here is a list of numbers. What is the modal number? 5 is coming up most common, so it's 5. Round 3,763 to the nearest 100. My hundreds column is here, so that will be 3,800. So we've got to work out this addition. We've got to give our answer in meters. So we need to clock this one here is in centimeters and change that so that it is in meters. You can then just go ahead, pop that in your calculator and get your final answer of 3.84. Again, this is one we can just put directly into our calculator. Use your fraction key. Remember, of means times. So you will multiply it to the 42 and you will get the answer 18. Write down the next two terms in the sequence. Well, I need to look and see what the sequence is going up in. So I can work out and see that that's going up in 4s. It's doing it every time. Double check, make sure by doing at least 2 or 3. Once you're satisfied it's going up 4 each time, you will literally just add 4 to the 13 for the first one and 4 to the 17 for the second one, and you'll get a mark for each of those. So does 38 lie in the sequence? Now, you could list them all out. Just keep that sequence going until you get there so that you can answer the question. Or in this particular case, if we take a good look at the sequence to see what we can get from that, I can see all the numbers in the sequence are odd, whereas this is even. So no, the sequence is odd. So 38 won't fit because it is even. Okay, we've got 4 cards with the numbers 6, 5, 7, and 2 on them. We're using the cards once, and we've got to work out the greatest even number we can make. Now, we would automatically try and make the 2 biggest possible numbers and see what we get with that. Now, when we add that, and remember, we've got our calculator, I've got an odd number. So by putting those together, that's not going to work. Now, you can keep trialing, write them all out until you find the biggest one. But we want to keep going with that idea of writing the biggest possible numbers. So let's use the 72 again, because that really is the biggest, and just swap the other 2 around, which would give me 56. And when I add those together, I get 128, which is even there on the end. So those are the way I'm going to arrange it. Equally, I could have put 56 first and the 72 second. Okay, there are 4 people in a darts match, and each player will play every other player once. And we've got to write down all the matches that take place. So Harry is going to play Peter, and he will play Ellen, and he will play Bob. I'm then going to do what Peter does. So I'm doing it in a logical order so I don't get confused. Now, Peter's already played Harry, so we just need to write down that he's got Ellen and Bob left to play. Then we can look at Ellen. Well, Ellen's already played Harry and Peter, so Ellen's just got Bob left. And then if we start to think about Bob, we can see that Bob's already with Harry, already with Peter, and already with Ellen. So we absolutely don't want to add any more. We've got all the possible matches that will be created if they all play each other once. Okay, so we've got a pictogram. It's all about a number of people that visited a museum on each of 4 days. We're being told that our symbol represents 64 people. So this is quite a large number for a pictogram. How many people visited the museum on Monday? Now, my advice would always be to work on the key before you start answering the questions. We know that the entire symbol is worth 64. So let's start breaking it down. If I was to half the symbol, that would be worth 32. If I was to half it again, that would be worth 16. By taking that little bit of time, I now know that every one little square is worth 16. And that's going to be really useful when I start looking at these types of symbols where they're broken up. Now I'm going to crack on and answer the question. So how many people visited the museum on Monday? Well, I've got 3 full symbols. So that would be 64 times 3 plus 2 squares, which I've already worked out is 32. I would pop all that in my calculator and it's 224. 176 people visited the museum on Friday, and I need to show that. So what I would do with that is I would divide it through by the 64 to see how many 64s I can get. The calculator is telling me 2.75. So I know I can get 2 full. And then again, it's really down to how you see the mass. 0.75 is 3/4. So I just need 3/4 of our symbol. Equally, you could have multiplied the 64 by 2, looked at the difference and worked it that way. I mean, there's generally more than one way with most questions, isn't there? The last question says, more people visited on Wednesday than on Tuesday, and we're being asked to work out how many more. So we're going to go back up and start looking at those totals. So on Wednesday, we have got 4 full symbols, and then we've got 3/4. So 3/4 is going to be these together, which is 48. So I'm going to add on 48, get that in my calculator, and you get 304. Similarly, we're going to do the same here. So 3 times 64, and then we've just got one little square from the symbol, which is worth 16. We pop that in and we get our 208. And we just need to now look at the difference between 304 and 208, making sure we show all our working out. And the answer is 96. Okay, so we're being told that 45 people went to a concert, and we can see that that 45 is already in our diagram. Each person's asked if they'd like to stand in the lower circle or sit in the upper circle, and 28 of these people are male. So I can pop 28 in there. That means I can work out the female. The males and the female add to make 45. So in my calculator, I'll do 45 take away 28 to get 17 females. Now, 7 of the 15 people that wanted to sit are female. So I've got female, sit, 7 is going in there. But they're also telling me that 15 people wanted to sit. So I've got a total of 15 going into those two circles. 7 is already here. So I just need to work out what I add to 7 to make 15, which is 8. And then I can finish it off. These two add to make 28. So we've got 20, and equally, these two add to make 17. So we've got 10. One of the people is chosen at random. What is the probability? It is a male that said stand. Now, probability, that word tells us that we should be looking to create a fraction. The probability that it is male that said stand. So over to the diagram, we've got our males, we've got our stand, and it is 20. One of the people's chosen. So there are 45 people in total, and that's what would go on the bottom. Okay, we've got two parts to this question. The first one is that we're being asked to translate the shape in the vector -2, 4. -2 is going to send us back 2 places. So what I'm going to do is really highlight what I'm up to. I'm choosing that corner to count from. -2 means I'm going to go back 2, and 4 means I'm going to go up 4. 1, 2, 3, 4 takes me to the 3. So I'm going to mark that corner in, and I'm going to highlight it blue as well, just to really make sure I don't make any mistakes. I'm now going to grow my new shape because it's identical in size. So 2 along, 1 down, 3 across, and then join it up. It does say that I want to label the new shape A, so I shall pop a little A in there. And then I have completed that. The next part is asking us to rotate A. Now, that's the one we've just drawn, not the original. We need to rotate it 90 degrees anti-clockwise using the origin, and we're going to label it B. Now, unfortunately, I don't have the software to demonstrate this as well as I would like. So I'm going to just kind of do my best. This type of question, rotation, is where you really want to grab that tracing paper. So this is my attempt at some tracing paper. You take the tracing paper and you make sure you've got your shape completely covered and the point that you will be turning in, which is the origin in this question. You trace your shape. Do it as neatly and as close as you can get to being right on top of it. Otherwise, when you do the twist, it might be slightly off. And if it is slightly off, you know that your new shape needs to be bang on the grid lines, just like the original was as well. We have a stabbing point here. So we will be holding our pencil at this point and then twisting the tracing paper 90 degrees anti-clockwise. Top tip here is just put a little marker on so that when you twist, it's easy to see when you have completed 90 degrees. Okay, so once you've twisted, you can see that my little marker has moved 90 degrees and my shape is now in its position. The tracing paper is telling me exactly where to put it. Okay, so once you've done that, obviously you'll have to move your tracing paper out of the way and get the shape popped in properly. And we've been told to label it B, so we will label it B. Okay, we're being told that the triangles are mathematically similar. That means that one is an enlargement of the other. So there's a scale factor going on in this question that we need to know about. They generally give you two sides that go together. Now, they've done a little twist to try and make it harder, but we're not going to let that fool us. BC is 8 centimeters. The same edge on the larger triangle is here at 14.4. So that's my connecting sides. You could say that was my fact. So I know that 8 centimeters on the small turns to 14.4 on the big. And basically, I'm going to use my boxes and labels to help me here. I want to find the edge DF, which matches on the small one with AB here, which we know is 6. I've kind of got a bit of a labeling system going here. I know that 6 is on the small triangle, so I'm putting it in the small column. 8 is my trapped number, so I am going to do 6 divided by 8 times 14.4. If this is the first time you've seen this method, the number in the corner, which is trapped, is always a denominator of a fraction. And then these two, it wouldn't matter if you put them either way, it's going to give you the same answer. This is a calculator paper, so we can just throw the whole thing in the calculator and we get 10.8. So our final answer would be 10.8 centimeters. Whilst we're here, I just want to mention that there is obviously different ways of doing it. So if you're sitting here thinking, oh my God, I didn't do it like that at all, obviously it doesn't matter. But the reason that I'm choosing to demonstrate this is because it works in an awful lot of places. So if you were stuck and you spotted that there was a fact in your question somewhere, if you pop them side by side and get the third number in the right position, then all you've got to do is get your trap number on the divide and boom, you're on your way with marks. So it's a lovely little method, that one. Okay, so we've got an awful lot of information to digest in this question. We're being told that Daniel is working out the cost of using his mobile phone. We've got the details of his contract. We've got the details of his usage, and we've got to work out that total cost that he must pay for his mobile phone in August. So this is one of those questions where you just need to kind of take it all in and then break it down. Just do it step by step. So we're going to, first of all, look at his usage. So he did 605 texts. If I go to the contract, I can see that his texts are unlimited. So there's going to be no additional charge for this. So actually, the information's there, but I don't have to do anything with it. Next, I'm being told that he's made 368 minutes. I go up to his contract. He gets 300 free. So he's going to have to pay for 68 minutes. Additional calls are charged at 0.10 pounds or 10 pence. So we're going to times through by that 0.1, which is going to tell us there's an additional charge of £6.80. As always, just get it straight in the calculator. As long as you're writing down what you're doing, it's all good. We've then got the data. He's used 28 gigabytes. He only gets 20 free, so he's going to have to pay for 8. So the information is telling me that he will pay £4.30 for 5 gigabytes. Now, I've got to work out how much that's going to be for 8. Now, this is a fact. So we're going to use what I just showed you on the previous question. I know that 5 gigabytes is worth £4.30. I want to work out what 8 is. Now I can leave it like that. I can put it in the box, whatever's comfortable. I could also have written this the other way around and it would still work. So there's no kind of hard and fast rule there. 5 is my trap number. So I will be doing 8 divided by 5 times 4.3 into my calculator, which gives me 6.88. So I know that the extra gigabytes is 688. One thing I must not miss is this monthly charge. That needs to be added into all these extra costs here as well. So we're going to do £22 plus all of this to get our final answer. Put it in your calculator and your final answer is £35.68. Okay, so we've been given a formula and we've got to work out what P is when T is 6 and D is -3. What we want to do is 8 times, because it's squashed, to T, which is 6, take away 4 times D, which is -3. Now, don't start trying to do this by hand. You have a calculator. They expect you to use it. Literally put that in the calculator. The calculator will give you the answer and you will get 2 marks. You've clearly shown the maths and you've got the result. The second part's a little bit harder. We've obviously got our rule P equals 8t minus 4d. We're being told that P is 11.2. So I'm going to put 11.2 where my P is. I'm working out T. I don't know what it is. So I've still just got 8 times something. And then it's take away 4 times 2. I've got 11.2 equals 8t minus 8. And now I'm going to start working to get 8 on its own. If you don't like your equations back to front, then you can always rewrite them, just rearrange it the other way around, and then you might feel that you're in more of a comfort zone with it looking like that. We're going to take the 8 across. It's a negative or a -8 on this side, so it's going to land as a plus on this side. So that's going to give me 19.2 equaling 8t. To get t on its own, I need to move the 8. It's a times on that side. It will land as a divide on this side. And when you pop that in your calculator, you get 2.4. So t is 2.4. Okay, we're being asked to write the nth term for the sequence. So we need to take a look at how it's going. It's going up 7. Check it's doing it each time. It is. Our gap is squashed to the letter N. So whatever our sequence is going up in, that's the number we put next to the N. And then we just go back, go in the opposite direction, which means I'm going to be taking 7 off. 3 take 7 is -4, and that is my nth term for the sequence. Okay, we're being asked to create a ordered stem and leaf diagram from the information that we've been given. I am actually going to create 2 diagrams. The first one is just about getting every single number in. The second one will be to order it. I find if we take this approach, it may take a little longer, but you are more likely to get it accurately done. And let's be honest, many of us have time at the end of our exam, so we've got time to take on these questions. So the first thing I'm going to do, as I say, is just transfer all of my information across. By crossing off as I go, I have got every single number in my stem and leaf. Now I'm going to order it. And I've tried to be a little bit neater on that one because I know it's my final stem and leaf diagram. So I've done exactly what they've asked. I've drawn an ordered stem and leaf diagram, but I will not get full marks unless I show a key. Whenever I draw a key, I really just sort of zoom in on this section of my diagram. I've got a 9, I've got the line of the diagram, and I've got a 2. And that value was worth 92. So if I just pop that down, that's going to get me that last and final mark. The second part of this question is asking to find a median. Now, I don't want to start ruining my diagram by drawing all over it because I might lose marks. But the reality is this is a predicted paper and I wanted to put these 2 different skills into the one question. They're not likely to ask you to draw something and then scribble all over it. So it's more likely you'll see one or the other. So if you're being asked about a median, they've probably already drawn it for you. To find the median, we just obviously need to cross off until we find the middle. I'm a bit lazy. I like to cross off in chunks. So you would always cross the smallest with the biggest, the next smallest with the biggest. But as I say, I can get a bit lazy. So I'm going to just do a chunk. I'm going to go 3 small ones and then go back 3 big ones. Go forward a couple, go back a couple. I don't go crazy because I don't want to lose my place. I've got 2 and 3 left. So I want to be slap bang in between those 2. So my answer for part B would be 122.5. They could ask about modes, they could ask about ranges. So just be prepared. If a stem and leaf is in paper 3, you could be drawing it or you could be answering questions about it. Okay, so this question is asking us to change from meters squared to centimeters squared. The other type of question that we see like this is our kilometers per hours to seconds type things. And it's like always a bit of a, which one should we go for? So hopefully we'll see this. Now, the way to do it, the first thing we need to do is to get a connection between our units. The best way to do this is to consider what those units are. A meter squared means you've got a square that is 1 by 1. That is equal to 1 meter squared. Now take that same square and instead of labeling it with a meter, label it with centimeters. Now when you multiply to get the area, you have 10,000. So the link between these two is a times or a divide, depending on what the question is. But in this case, it's a times of 10,000. So we've got 2.4. We need to times it by 10,000, and we will end up with 24,000. Okay, we're being asked to estimate the mean distance cycled. Mean. How do we find the mean? We add, then divide. But this mean is in a table. So this is the MAD method. The MAD method tells us to multiply, add, divide. So my first step is to multiply. So I come up to this table and I've got to decide what it is I'm actually multiplying. I have got 6 cyclists that cycled a distance between 0 and 50, but I don't know what they cycled. Could have been anything as long as it was in that range. So what number do I use? I use a number that's fair. I use the midpoint. So I will be taking the midpoint and multiplying it to the frequency to get my result. And I'm going to do that on every single row. Once I finish my multiply stage, I'm going to add. Now, obviously, I'm going to add this, or there wouldn't be a lot of point in doing it. But I'm also going to add the frequency. I want to know how many are there. Remember, mean is add them all up and divide by how many are there. I am also told that information here in the question. My last step is to divide. Don't round, don't do anything with the question unless you are told to. That is my final answer. Okay, so this question is asking us to write down the reciprocal of 0.35. First thing you want to do is put 0.35 into your calculator, press equals, and get your fraction version. So that is the equivalent fraction to the decimal. A reciprocal is a flipped fraction. So you just flip it yourself, and that is the answer. If you had a whole number, let's say you had 3, and you had to flip that, you need to obviously just put it over 1 first, and then you can get that flip done. All right, we've got some indice rules being tested, and the next question. I've got 4 to the power of 5, which I can put into my calculator, and it's 1,024. And then I've got my power rule, which is to multiply. Use the bracket to remind you that you multiply. That's sometimes useful. So it's going to be y to the 15. The next question is a divide question. When we divide powers, we take them. So to do the number work first, 36 divided by 9 is 4. Then we've got a to the power of 3 divided by a. Now remember, there's a visible 1, and we have to take the powers. So I've got a to the power of 2. And then our b to the power of 5 is dividing by b to the minus 2. We take the powers. And what we've actually got here is 5 minus minus 2. That becomes an add. And 5 plus 2 is 7. So it's b to the 7. But be so careful, because when they bring those negatives in, it's really, really easy for it to go wrong. All right, our next question. Amy buys a car for 26,400. The car depreciates by 6%. Right, I've got a percentage, and depreciate means decrease. This question passes the 2-tick test, so I know it's original times multiplier equals result. And it's my job to work out the multiplier. It's a decrease, so I'm going to be doing 100 minus 6, which is 94. Divide that through by 100, and I've got 0.94. So multiplier is 0.94. Read the question carefully, because it's not always automatically the original that they give you. It depends on the question. Sometimes they give you the answer after it's performed, and then you would put that in the result. But we've got the original. The original cost is 26,400, and that will get times by the multiplier. But if I read on, I can see that the value of the car needs to be found after 4 years. I've got a period of time. When I've got a period of time, that becomes an add-on to the multiplier, and it's a power. So I'm going to have the power 4 going onto that multiplier. I just pop that in my calculator, and I get 20611.7725, on and on it goes. It's a money question, so I'm going to round for money. And that's my final answer. Okay, so we need to find the highest common factor of A and B. We don't actually have to work out the prime factors because that's been done for us. So don't put this into your calculator to get the actual total, because it's not going to actually help you. What we're going to do is we're going to draw a Venn, and we're going to list out the numbers. If you're quite practiced at this, you probably won't need to list. But if you're not, then this is absolutely the best way to do it. Okay. Got to write the 5 7 times. Okay, now we want to pair up what goes together. So I've got 3 5s that can go with those 3 5s, and they get popped in the middle. I've got 2 7s, which should go with those 2 7s. And then I've got 4 11s that can go with those. I don't need to populate the rest of the Venn, because I'm only interested in the highest common factor, which is this section here. They want me to give the answer as a product of powers. So I have got 5 to the power of 3 times 7 to the power of 2 times 11 to the power of 4. So we've got a number that's been rounded to 2 decimal places, and the result is 5.62, and we need to write down the error interval. First thing is to create the 2 decimal place number line, and the one before, and then just pop on those arrows to show that you are looking for the middle value, the value that lies between them. So our first number is 5.615 and 5.625. So the midpoints are what we're looking for there. Okay, we're being asked to complete the tree diagram. We've got 30 students attending a dance class, 18 like modern and the rest like tap. They've started it for us. So if 18 out of 30 like modern, then 12 out of 30 must like tap. Now, 2 students are picked at random. So our diagram is saying here that 18 out of 30 like modern, and that's our first student picked and gone. So when we are picking our second student, there is only 29 left to choose from, and that's why this fraction has changed. There's also only 17 left in the room, if you like, that want or like or prefer modern. That means 12 out of 29 are still left in the room liking tap. However, if we went in this direction, the first student picked would have liked tap. So someone liking tap has kind of left the room. That means that only 11 people remain. And that's out of the 29 left. And all 18 of our modern dancers are still in the room. So that's how that diagram has come together. And we've got 2 marks for that. We've got to work out the probability that 2 students picked at random both like tap dancing. So our first student liking tap is there. Our second student is there. So we've got the fractions, 12 over 30 and 11 over 29. Now, they are not our answers. We want one final fraction as our probability answer. You will always multiply when you're in a tree diagram. So you collect up your fractions and then you multiply them. If you were to do it separately, you would end up with this. That's fine. If you did it as fractions into your calculator, you would end up with this, which is an equivalent and is also correct. Our next question is regular polygons. Regular polygons means that all the edges and all the angles are equal. And there is a lovely formula triangle. So the minute you read that, I can't recommend highly enough that you draw 360, X'd for exterior and sides. And that will help you get started in any problem, no matter how complicated it is. Now, we're being told that A, B, C, D, so A, B, C, D, D, C, E, F, so D, C, E, F, and B, C, E, B, C, E, we're being told that they are all identical regular polygons. So that is the same shape being put together. They want us to work out the mathematical name of the polygons. In order for me to do that, I'm going to need to know how many sides it's got. I've got an interior angle on this, an interior angle on this, and an interior angle on this. So on my 3 identical polygons, they are coming together at a point. 360 divided by 3 is 120. So I know that the interior angle of each of these is 120 degrees. If I look at my triangle, I don't want an interior, I want an exterior. The exterior lies on a straight line with the interior. So I shall just take the 120 from 180 and I've got 60 degrees. That's my exterior. Now, if I do 360 and divide that through by 60, I get 6. That is my sides. And a 6-sided shape is called a hexagon. Okay, the question everybody loves to hate. I don't know anybody that I've ever tutored or had in a class that has said, I love these. So we've got 8 taps all working simultaneously to fill a swimming pool, and it takes 192 minutes. We got to work out how many minutes it would take if there were 3 taps. Well, if there were fewer taps, it's going to take a lot longer. So that's the first thing for us to really make sense of. We know that we want our answer to be bigger. The best way to approach this is to think about what 1 tap. 1 tap is going to take 8 times longer than 8 taps. So we're going to do 192 times by 8, which gives us 1,536. And that is 1 tap. I do have 3, so that total number can now be divided through by those 3 taps to give me my final answer of 512. I'm also being asked to state an assumption that I've made, and I have assumed that they are all flowing at the same rate. Okay, we're nearly there, down to our last three. So this question has an isosceles triangle inside a semicircle where each corner of the triangle lies on the circumference of the semicircle. So maybe the first thing I want to do is just mark on the fact that it's isosceles. And these edges here are the two shorter ones. So we will be marking those on as the isosceles. We're told that the area of the semicircle is 240 centimeters squared, and we need to work out the area of the triangle. Okay, so the area of the triangle is going to be base times height divided by 2. Looking at my diagram, I need the base and the height of my triangle. Now, they are also the diameter and the radius of the semicircle. So this fact about the semicircle having an area of 240 is what's going to help us get the numbers we need to find the area. So let's get going and see how this works. We know that the area of a circle is pi r squared. We only want half the circle, so we will be dividing our answer by 2. Pi r squared divided by 2 is the area of a semicircle, which is 240. I'm now going to work to get r on its own, and then I will have a value for the height of my triangle. So I'm going to take my divide by 2. It's going to land as times 2, which is going to give me pi r squared equaling 480. I'm then going to divide through by my pi, which will give me r squared equal to 152.788, and on it goes. The 2 will come across, and it will square root to give r equals 12.3607, and on it goes. So I have got my r. I now need my diameter. A diameter is twice the radius. I just need to times that by 2, and then I've got my diameter, which is 24.721, and on it goes. The base, 24.7215, times by the height, the radius, 12.3607, divided by 2 is the area of my triangle, and that equals 152.787, and on it goes. Always read that last line again. Make sure you've answered it. Wants it to 3 significant figures. So 1, 2, 3, cut. The final answer is 153 centimeters squared. Okay, we've got another big question here. We're being told that we've got a right-angled triangle and a regular pentagon, and we can see from the diagram that they share an edge. So those lengths are equal. I've got to work out the perimeter of the pentagon. So if I can find this edge, I'll just times it through by 5, and that will give me the perimeter. So my focus really is on the triangle. I've been given a side and an angle. I'm recognizing this is trigonometry. I've got opposite, hypotenuse, and adjacent. I don't need the hypotenuse, so it's A and O. So, ka, toa. I want O and A, which is that one. So I've got tan 52, O, and 12.2. O is equal to tan 52 times 12.2. So I'm going to pop that in my calculator. Now, this is really important. I must make sure I close the bracket. The calculator will open up a bracket as I type it in, and I must close that, or it could go horribly wrong. That's going to give me 15.615, and on it goes. Times that by 5, because I've got 5 edges, and that is 78.076, and on it goes. It says give your answer to 1 decimal place, so 78.1 centimeters. Okay, our last question. Simultaneous equations. In order to solve these, my first step will be to get my x's the same. So I'm going to multiply the second equation by 3. So the top equation stays the same. The bottom equation, every term is multiplied by that 3. My next step is to take away each term, taking away the x's, the y's, and the numbers. 3x take 3x means the 3x's have cancelled each other out. They're gone. That's the idea. Now I can just concentrate on the y's. I've got 2 take away 24. That is going to give me minus 22y. And minus 3 minus 30 is minus 33. I'm going to divide through by minus 22, and y is equal to 1.5. And remember, you've got your calculator, so make sure you're using it. I'm now going to choose one of the two original, and I'm going to choose the bottom one, x plus 8y equals 10. I know that y is 1.5, so I've got 8 times 1.5 to give me x plus 12 equals 10. Take off the 12, and x is equal to minus 2. Well, that's it, folks. Do use those additional links to help you with the additional topics that you might see. I hope the paper has gone well for you. I hope Monday is brilliant and goes perfectly, and you get the results that you're looking for in January. If this has been helpful, please like and subscribe. It really helps my small little channel. And if I have to see you in January, if things don't go brilliantly, then please come back. I do the predicted papers, I do the topic busters, I do all sorts of things. I even have my own courses. So yeah, hopefully I will not have to help you in the future. You'll have got that grade you wanted. But if you do need more help, I am always here.